Hello, Math 7 students. This is Unit 1 Scale Drawings, Lesson 9, called Create Scale Drawings. Today's objective, let's create our own scale drawings. Let's get started. To begin, we can see a rough sketch of Noah's bedroom. Please note, this is not a scale drawing. Noah has just sketched out the general shape of his room so that he can see where the door is, and so that as he's measuring things, he has a place to document those measurements. He does want to take this information and actually create a scale drawing. We're going to help him out. It says the actual length of wall C is 4 meters. When he draws his scale drawing, he wants to represent wall C with a segment that's 16 centimeters long. And the first question is, what scale is he using? Now I want you to be careful with this question. Sometimes when we hear that word scale, because we've had so many lessons, we jump to scale factor. And that thinking is right on track, but it's not exactly what this question is asking. So to set up this problem, I want to set it up the same way that we have all of the others. I want to create two separate columns. I want to have a column for however long things are in the drawing and however long those things are going to be in the actual real world. So I'm setting up two separate columns. And as I read one more time, it says the actual length of wall C is 4 meters. So wall C is actually 4 meters. Now I'm going to put that in two places. I want to list it here where it says wall C, but I also know that this is the actual length, so I'm going to put that measurement in the actual column. That actual length represents wall C, so I'm going to go ahead and make sure I give it a label as well. Again, when Noah draws this segment on his scale drawing, he wants it to be drawn as 16 centimeters long. So the drawing is going to be 16 centimeters. Now remember, the scale, if we remember from our last lesson, is a statement that connects how long something is in the drawing to how long it is in the real world. So we have already written the scale. Although we want to make connections between the numbers, the scale is this whole entire statement. So the scale is 16 centimeters represents 4 meters. If you're a lazy mathematician like I am, I might just use a colon instead of the word represents. Because really, when we have scale drawings and we have these measurements, it is just a ratio. Question 2 says, find another way to express the scale. All that means is we like to simplify our ratios. The chances of us always drawing 16 centimeters at a time is pretty rare. Another thing to notice is we don't have a unit at all, a unit meaning 1. It would be really simple if I could turn one of these numbers into a 1. You can decide which number to turn into a 1. The one that I think is going to be the easiest is what if, instead of 4 meters, what if I represented that as 1 meter? 4 meters can change to 1 meter by simply dividing by 4. And since we're thinking of this as ratios, let's go back to 6th grade with our ratio thinking. Whatever I do to one part of the ratio, I have to make sure I do to the other part. So I need to make sure I divide the other part by 4 as well. 16 divided by 4 is equal to 4. So another way that I could express this ratio, express the scale is as the ratio 4 centimeters to 1 meter. Another way to think about this, notice that 4 and 16 both have a common factor of 4. That means if I take 4 and divide it by 4, I'll still get an integer. And if I take 16 and divide it by 4, I will still get an integer. So that's another way that you can change or simplify the ratio is by simply dividing out any common factors that you find. Let's continue on to number 3. It lists the actual measurements of wall A and D. I'm going to color code here. It lists wall A first, wall A, and then it lists wall D. So when I continue reading and it says the actual lengths of wall A and wall D are, and then it lists those two extra measurements, that means wall A, which was listed first, is going to be the first measurement that it gives me. So wall A is 2.5, and wall D was the second measurement, or the second wall listed, so it's going to be the second measurement given. Wall D is 3.75 meters. Again, I'm going to put that information in two different places. I'm going to put wall D and list that right here as 3.75 meters. And wall A is 2.5 meters. Just because I want to label my diagram, it's going to make this problem easier to think about. But I also want to list those measurements. Again, these are actual lengths in the bedroom. So I want to put these actual lengths in my actual column. Wall A is 2.5 meters. And again, I'm going to give that a label. And wall D is 3.75 meters. Now that we have all of that information organized in our two separate columns with labels, now I think I'm ready to determine how long all of these walls are going to be in Noah's scale floor plan. Explain or show your reasoning. That's what I'm doing when I put all of my information in these organized tables. I'm explaining and showing my reasoning. So again, we want to look for connections as we go across this table. So one of the things that's worth mentioning, in the drawing, I'm measuring in centimeters, and in the actual, all of these are measured in meters. So when I find out what these measurements are in the drawing, I do know that they're going to be centimeters. So now all I need to focus on is a connection between the numbers, 16 and 4. And the truth is, you can go in either direction. You can even use this simplified version if you would like to, where I can call it 4 centimeters to 1 meter. That would be our simplified scale. And when I use smaller numbers, that might be easier to see. How does a 4 change to a 1? Or how does a 1 change to a 4? We can change a 1 to a 4 by multiplying by 4, but pay attention to the arrow. What direction did I go? We can also change this 4 into a 16, but again, pay attention to the arrow and what direction I went. Now, I'm going from 2.5, and I want to know what is that going to be when I make it over here to the drawing column. But notice I'm going the same direction. Actual multiplied by 4 to get to the drawing. 1 multiplied by 4 to get to the drawing. So that means 2.5, I'm going in the same direction. So I will multiply by 4 to get the actual, or the length that it's going to be in the drawing. Go ahead and use your calculators here. 2.5 multiplied by 4 is equal to 10. Don't forget to change our units. Yes, in the actual, we're measuring in meters, but now that I'm in the drawing, I'm going to measure in centimeters. Now we're going to do the same thing. We're going across this way, going in the same direction, so that means I'm going to be multiplying. And I have 3.75 multiplied by 4 is equal to 15. Don't forget our units of measure change to centimeters. We're going to skip the "Are you ready for more?" Let's move on to Utah. Now, my students live in Utah, so you're really familiar with the shape of Utah and you can explain it. Every time I ask my students to explain the shape of Utah, they'll often give me different things like, well, it's like a rectangle with an extra rectangle on top. But most of the time, students will say it's like there's a rectangle, but the state of Wyoming came and took a chunk out of it. And so that's the way that I'm going to think about this particular problem. I want us to imagine that there is a rectangle that goes all the way around the entire outside of Utah. And when we do that, we know that there is this chunk of that rectangle taken out because that is part of Wyoming. The reason I want us to think about Utah in this particular way is because I'm about to give you some measurements. On your paper, you're going to see it. The rectangle around Utah is 270 miles wide and about 350 miles tall. The upper right corner that's missing is about 110 miles wide and about 70 miles tall. So again, if I envision this Utah being a rectangle, I know that that rectangle is 350 miles tall and about 270 miles wide. And I know that there's this chunk that is cut out, and that chunk that's cut out in that corner is 110 miles wide and 70 miles tall. I keep saying M for meters, but it should be MI for miles. So that is what I'm going to see labeled here, much neater. So there's the measurements of Utah. Again, you can see the rectangle and you can see the chunk cut out. What I need to do with this, though, is we are going to create our own scale drawing of Utah, and we're going to do it twice. So before I begin drawing, I need to make sure that I know how long to draw each side. So if you take a look at your paper, it is broken up into two sections here. We have this section here where it says make a scale drawing of Utah, where 1 centimeter represents 50 miles, and another one where 1 centimeter represents 70 miles. So the first thing I need you to do, if you're following along with me, I need you to split that paper in half so that we have enough space to do both of those versions. I don't want to overflow and take up more space than I need. So we're going to split that up. And now I'm going to focus on this one first, where 1 centimeter represents 50 miles. Now, because this is where I need to draw Utah, I'm going to have to list all of my information somewhere else. So I'm going to come up here and I'm going to write all of this down here. If you have a scratch sheet of paper, this would be a great place to do that. If you want to go and grab a My Favorite No paper, if you're sitting in the classroom, you're going to do this on a scratch piece of paper. And I'm going to begin the same way that I have every single problem, where I am going to set up my two columns, one column to represent all of the drawing measurements and one column to represent all of the actual measurements. With that in mind, the first thing that I want to list is the scale. The scale is the foundation. It tells us 1 centimeter is going to represent 50 miles. That is what connects the actual to the real life. So that is the first thing I'm going to list. 1 centimeter in the drawing will represent 50 miles in the actual Utah. Give it a label. This is our scale. And before I even start doing anything else, there's something really important here. Notice centimeters in the drawing are measured as miles in the actual. So now I need to focus on the connection between the numbers. I have a 1 and a 50. Start thinking, how does a 1 change to a 50? Again, that's mental math. A 1 changes to a 50 by multiplying by 50. Now we can start listing all of these other measurements that we see, like Utah is 350 miles tall. So this is going to be the height. And the height, the actual height, is 350 miles. I don't know how long that's going to be in the drawing, but that's one thing I need to find out. The width of Utah is 270 miles. So I'm going to label that. The width is 270 miles. Now remember, this would be a rectangle. So this is also going to be the height of 350 miles, and this is also going to be the width of 270 miles. But we do have this piece that is cut out, and that piece that's cut out is going to be 110 miles wide. So I'm going to say cut width, because it's the width I'm going to cut out. That's 110 miles. And the height that I'm going to cut out is 70. So I'm going to say cut height. And that cut height, again, the actual distance is 70 miles. So it looks like I have all the information for actual. I need to take all the information for actual and figure out how long do I need to draw each of those pieces. And the connection is right here. 1 centimeter is going to change to 50 miles. In other words, 1 is changing to 50. How? We multiply by 50. But that's if I'm going forwards. And you can see I'm not going forwards in the table because I don't know what is really here. That means I have information on this side of the table and I need to work backwards. So if going forwards I multiply by 50, then going backwards I'm going to divide by 50. And I'm going to divide by 50 here, and here, and here, because each time I'm going backwards. Let's get started with those calculations and let's document them on our paper. 350 divided by 50 is equal to 7. Don't forget, we're also changing our units of measure to centimeters. The width is 270 divided by 50. So the width is going to be 5.4 centimeters. Now it's time for the cutout width. That still is 110. So again, I'm taking this number, working backwards, dividing by 50, typing it into the calculator, and I have my cutout width is going to be 2.2 centimeters. And our last calculation, starting at the 70, working backwards, dividing by 50, I type in 70 divided by 50, and I get a distance of 1.4 centimeters. Now I'm going to take all of this information. Let's see if my technology will cooperate. I'm going to take all of this information, and just so that I can see it as I am attempting to draw this, I'm going to just move it down here. That way I can see everything that I need as I'm getting ready to draw it. So let's get started with the actual drawing. Now, because of the work that I've already done, I know how long each of these pieces need to be. So I'm going to start with the height. The height is 7 centimeters. Again, make sure you're using the centimeter side of your ruler here. And I'm going to draw that height to be 7 centimeters. So here's the 0. Go all the way down to the 7. That's going to be the height. The width is 5.4 centimeters. That means I need to draw 5.4 wide. I'm going to zoom in so I can try and get this just right. And I'm going to go over 1, 2, 3, 4, 5.1, 2, 3, 4. Now, I need to finish up that rectangle, so I need to draw another height that's 7 centimeters. This time I'm going to line up the bottom part there at the 7, and I'm going to draw until I get up to the 0. You can always rotate your ruler in the other direction as well. I can't get it just right. It'll have to be good enough. And again, I'm going from 7 all the way up to the 0 to draw the whole rectangle that goes around the outside. I'm going to finish that up with another width, which hopefully is going to be 5.4, just like it was down at the base. If it's a little bit off, it's okay. Just do your best to make these right angles, since Utah has all of those right angles. All right, I now have my entire height and width. So now I need to cut out a width of 2.2 centimeters from the corner with a height of 1.4 centimeters. This is where it gets to be really interesting. So again, I'm going to come over here, and you can see on my ruler right here, 0 to 2.2. So what I'm actually going to do is, instead of lining up the 0, I'm going to line up that 2.2 right there at the edge. And when I draw over to the 0, that's how I know I've gone down enough. And I'm going to give myself 2 little marks because I don't know exactly, but I know that it's going to be a line somewhere around there. Now I need to do my cut height of 1.4. So I'm going to do a similar thing where I'm going to take my ruler and twist it. And I'm going to find that 1.4, and the 1.4 is what I'm going to line up there at the top. And I already know how far over I need to go because I've already measured 2.2 over. So I know now that that is 1 from 0 to 1 to 1.4. I need to go and cut out that amount. So I'm going to make that mark there. Maybe slide it over and make it somewhere else. All right, let's see if I can cut out that piece there. That piece that needs to be from here to here and here to here. And I can cut it out by just scribbling out the section, or if you have an actual eraser, maybe you can erase the lines that you initially drew. And that's it. That is my scaled copy of Utah. Now, all of that was done absolutely beautifully, but we are not done. In this section, where I had to move all of my notes, which I'm now going to erase, we need to draw another one. Because in this section, we're supposed to draw another scale drawing of Utah. This time, 1 centimeter is going to represent 75 miles. So let me get rid of all of this. Once again, I'm going to come back up here to do all of the work that I did before. This time, using a scale of 1 centimeter, represents 75 miles. So again, if you have that scratch piece of paper, you can use another section of it or flip it over to the other side so that we can document all of our new measurements for our new scale drawing. Again, getting started the same way, where I'm going to list the drawing measurement, the actual measurement, and leave yourself enough space so that we can give ourselves the labels. Again, we have a height of 350 miles. We have a width of 270 miles. We have to cut out a height of 70 miles. And we have to cut out a width of 110 miles. Those are the same measurements that we used before because they're the actual measurements of Utah, but here's the part that's different. Now, the scale that I'm using is 1 centimeter represents 75 miles. So, that scale is what connects everything together. So I'm going to list it as 1 centimeter, which is representing 75 miles in our actual state of Utah. So now, new scale, but we still ask the same question. What's the connection between these? Yes, we see centimeters and miles. Units are changing. But how does a 1 change to a 75? Again, that's very simple. Whenever we have a 1, 1 times whatever is that new number. So 1 times 75 is equal to 75. Unfortunately, we're not going forwards anywhere here, but if I know how to go forwards, I also know how to go backwards. So if going forwards, I'm multiplying by 75, going backwards, I will divide by 75. So every one of these will be divided by 75. So let's go through these step by step. We are going to begin with the actual height is 350, going backwards and dividing, and I have 350 divided by 75 gives me, and I know it's not very pretty, it's not very nice, when you type it in, you get 4.66666, and that 6 repeats. We're going to just make it nice and simple for ourselves. That 4.66666 is eventually just going to round up to 4.7. So that's what I'm going to do here. We're just going to call it 4.7, but let's make sure we change our miles to centimeters in the drawing. We're going to repeat that process for each place. 270 is our width, and 270, going backwards, dividing by 75, type it into your calculators. And 270 divided by 75 is equal to 3.6. Change the units to centimeters. Let's do the next one. Our cutout height. 70 miles is now going to be divided by 75. So let's type that in. 70 divided by 75 is equal to, again, it's another one that's not so pretty. We end up with the 0.93333. Let's just make it easy. Let's just call that a 0.9 centimeters. And our final one, I need to figure out how wide it's going to be when I cut it out. So I have 110, which is going to be divided by 75. Type it into your calculators. 110 divided by 75 is equal to 1 point, again, it's not nice, 1.466666. But eventually, all of those 6 are going to round that 4 up to a 5. So I'm going to write down 1.5 centimeters. And again, just like I did before, I'm going to take all of those. Ooh, this is not going to fit very nicely. I'm going to try and squeeze it in all the way down here. Now I know how big I need to draw each of those new pieces here. So let's get out my ruler. I need a height of 4.7 centimeters. So I'm going to get started with the height of 4.7. Starting at the 0 and drawing down 1, 2, 3, 4.7. Okay, next I need a width of 3.6. So I'm going to rotate that, line up the 0 with the line I've already drawn. I'm going to measure about 3.6. There's the 5 and the 6. And again, I'm going to build that rectangle that goes around Utah first. So I'm going to draw the whole entire height of 4.7. Lining up that 0, drawing up 1, 2, 3, 4.5, 6, 7. And closing up that rectangle. This should hopefully be 3.6 across. Looks pretty good. There's that whole rectangle. But remember, Wyoming took a bite out of Utah in the corner. And that bite is, we're going to cut out a height of 0.9 centimeters. So I'm going to rotate this again to be 0.9 centimeters. Oh, come on. There we go. .9. Looks like it would be cut out about there. And a width of 1.5 centimeters. So again, I'm going to line up that 1.5 right there on the edge. Looks like it's going to go to there. Do one more spot. All right, so the amount that I need to cut out is about like that. So again, you can just scribble it out, or if you can erase it, we can go ahead and erase that whole corner. And there we are. Here's one of the most interesting things about these two drawings when I have them side by side. When I take a look at the scales of the two different ones, I have 1 centimeter that represents 50 miles, 1 centimeter that represents 75 miles, but which one is the one that ended up smaller? And a lot of times it's quite a surprise to us which one ended up smaller. And the reason it happens is 1 centimeter represents 50 miles. So let's say this is about 1 centimeter. That means here's 50 miles. And that same centimeter over here now represents even more distance. So that means I can represent the same large actual real life distance with less space on my paper. That's the end of that. So let's summarize. Let's take a look at the notes to our future forgetful self because we always forget after a couple days pass. So let's take some notes now that we can read later. Suppose there are two scale drawings of the same house. One uses a scale of 1 centimeter to 2 meters, and the other uses a scale of 1 centimeter to 4 meters. Just like we saw with the Utah, they are going to be different sizes. And the one with the 1 centimeter to 2 meters is larger. And it always feels backwards why that is. But it's because it takes 2 whole centimeters to represent 4 meters. So, again, let's approximate. It would be 2 full centimeters, and those 2 full centimeters would represent 4 meters on the actual, where that same distance using the other one, that same distance of 2 centimeters would actually represent 8 meters. So we can shrink up how much space we're taking just by changing the scale factor. In our given example, a rectangular swimming pool measures 50 meters in length and 25 meters in width. We need to make a scale drawing of the swimming pool where 1 centimeter represents 5 meters. You're going to notice down below is where it says, what are the length and width of your scale drawing? Well, let's do that first. To make sure I have enough space, I'm actually going to do all of the work for that problem over here in my helpful tips. My helpful tips are make your 2 columns. Have a section for the drawing measurements and have a separate section, a separate column for the actual measurements. And the first thing we should list is the scale. It says make a scale drawing where 1 centimeter represents 5 meters. So that's going to be the first thing I do. 1 centimeter represents 5 meters. This is the scale. Then when I continue reading or when I reread it again, I can see that this rectangular swimming pool measures 50 meters in length, 25 meters in width. So let's write that down. 50 meters in length. I'm going to give it a label of length. 50 meters is the actual distance and 25 meters in width. So I'm going to give it a label. That's the width. And it is 25 meters. So it looks like when I organize this information, I need to find how long to draw it and how wide to draw it. And in order to do that, again, let's always acknowledge I'm measuring in centimeters in the drawing, meters in the actual, but now I want to look for a connection between the numbers. Do you see how 1 and 5 could be connected? How does a 1 change to a 5? We multiply by 5. So what am I going to do to go backwards? We need to divide by 5. So I have 50 going backwards and dividing by 5, and I get a new length of 10 measured in centimeters. And the width is 25. Working backwards and dividing by 5 is 5 centimeters in width. So how long and how wide should I draw these? Let's get started. Here's my ruler again. I need to draw the length to be 10 centimeters, which is just barely going to fit on my page. I'm drawing that length to be 10 centimeters. So from here, the 0, all the way over almost to the edge, there's my 10. And the width needs to be 5 centimeters. I guess I could have drawn it the other way. This is going to be better though. So 5 centimeters. I'm going to line up that 0 and go up 5. I also need to complete it, so I'm going to go all the way over to this edge, also go up 5, finish it up, completing that rectangle, making sure the width is 10 centimeters. It's always a good idea to label this as well. This is our 10 centimeter and this is our 5 centimeter. Now, this final example I would love for you to do at home for your homework. You don't have to draw, you do just have to calculate how long they are. So give it a try for homework. If you're stuck, go ahead and continue watching. It says an image of a book shown on a website is 1.5 inches wide and 3 inches tall, but it's on a computer screen. The actual book is 9 inches wide. So again, what is the scale being used? One of the best ways, my helpful tip for you, set up your columns. Even if you're tight on space, find somewhere else or get a scratch piece of paper. I'm going to list it here. Drawing and actual. And it says the drawing, or in this case, the picture that's on the website, is 1.5 inches wide and 3 inches tall. So again, this is the width. This is how tall it is. And then it says the actual book is 9 inches wide. So I know I have 9 inches. Where am I going to put it? Makes more sense to put it in the width. So it's going to go over here, 9 inches. Now this is the first time we've seen this. When I measure it in the drawing or in the photograph, it's inches. And in the actual, it's also inches. So that is really interesting. Now we just need to focus on how is it changing? How does this 1.5 change to a 9? This is another great example of I don't know. All of the other ones we were able to do today, we were able to just do with mental math, but I'm not sure how a 1.5 changes to a 9. So remember our strategy. Anytime we don't know how to go forwards, we work backwards and divide. So when I work backwards and divide, that means I'm starting here with the 9. I'm going backwards, so I'm going to divide, and I'm dividing by the number at the beginning. So 9 divided by 1.5, type that into your calculator, and you end up getting 6. All that tells us is that we're actually going forward by multiplying by 6. Test it out. 1.5 times 6 should be equal to 9, and sure enough it is. And that tells me I now know how to go forwards. That 3 is also going to be multiplied by 6, and 3 times 6 is equal to 18. And again, our units don't change. So what we started off in inches is still going to be measured in inches. That's it for today's lesson. Thanks for watching. We'll see you next time.